We've all seen those flashy ads for no-code AI agent builders, right?
Yep.
They promise this simple drag-and-drop thing where the AI just kind of figures it all out.
Yeah, the dream. Click, click, boom. AI agent.
But then you actually open something like OpenAI's Agent Builder, and, okay, you're not typing Python code line by line.
No code writing, true.
But you realize really fast that you absolutely need to understand programming logic. It's all about the structure.
That's the critical difference, isn't it? You trade knowing specific syntax, like Python commands, for knowing how to structure thought. Pure cognitive structuring.
And that's really our mission today. We want to give you a bit of a shortcut.
Yeah, let's dive deep into how this agent builder actually works. We'll look at the architecture, what it demands from you operationally.
We'll clarify those core parts, the components you have to grasp, and show you how to actually build a functional workflow. Make it smart, make it scalable.
We'll unpack the essential building blocks, talk about handling data, which is crucial, and then walk through building a movie expert agent step by step.
Right. One that can figure out if it needs the web or not. It's about getting something working, not just knowing the theory. Functional.
Okay, so to start, maybe let's break down let's call them the 3 main pillars you need for an agent that people can actually use.
Makes sense. Pillar 1 has to be the agent builder itself. That's the visual canvas, your workspace.
Right, where you drag the blocks, connect them.
Exactly. And
Yeah.
crucially, where you write the instructions, the prompts for the AI. You design the intelligence there.
Mm-hmm. Then pillar 2 is the chat kit. Now, this isn't just a chat window for testing. Think of it more like a bridge, an API bridge, technically.
API meaning, like a standardized way for programs to talk to each other.
Precisely. A reliable way for your workflow's inputs and outputs to connect to, say, your website or your app. ChatKit is how you deploy the agent so real users can interact.
Okay, builder for design, ChatKit for deployment. What's the third pillar?
Widgets. This
Yeah.
is all about the look and feel, the aesthetics.
So controlling how the AI's answers are presented.
Exactly. Instead of just spitting out plain text, you can use widgets to structure the output. Maybe make it look like a nice movie card with the poster image and details, a proper user interface element.
Got it. Builder, kit, widgets. And everything kicks off when a user types something in, right? A message.
Yeah, currently every workflow starts from that user chat message. And you gotta understand, this isn't like, say, Zapier, where you just connect A to B simply. This tool demands real logical thinking. You're building a decision engine.
Okay, so let's get into those building blocks, the actual logic pieces you use to build that engine. The first one seems obvious, the agent block.
Yep, that's the core AI brain. Inside that block, you define the instructions, you pick the model.
Like choosing between GPT-4 for maybe harder logic versus 3.5 for speed.
Exactly. You set the reasoning effort, you give it tools, like enabling web search. It's foundational.
But you can't just have a brain running forever. You need an off switch.
Yes, absolutely. The end block. Seems simple, but it's crucial. You have to tell the workflow when to stop after the task is done. Otherwise,
Otherwise, you're just burning credits, right?
you got it, wasting resources.
Then there's the notes block, which sounds pretty straightforward.
It is. Purely for comments, reminders for yourself or your team. Doesn't affect how the workflow runs at all. Just good organization.
Okay, essential housekeeping. But the real powerhouse, the core of the logic, seems to be the if-else block.
Oh, absolutely. That's the cornerstone. Classic logic. If this condition is true, do this path. Otherwise,
Do the other path.
else.
Right.
It's how you split the road, how you send someone asking about an order down one path and someone asking a general question down another.
That feels very much like programming, just visual. Does structuring it this way actually make it that much easier for someone who isn't a coder? Why not just use code then?
That's the interesting part. It forces sequential step-by-step thinking. It makes you break down a big, complex problem into these simple binary choices, like stacking simple Lego blocks of data. That forced simplicity is the power.
Right. So once you've got the basic decision logic down with if-else, we need to talk about memory and how agents can pass information cleanly between each other. Data handling.
Right. Like, how does the agent remember my name if I told it earlier? Short-term memory.
Exactly. For that, you use the set state block. It lets you save a variable like username and you store it. Then any block later in that same conversation can just pull that value. No need to ask again.
Okay, so set state is for memory within one conversation flow. What about agents talking to each other?
That's where the transform block becomes incredibly important. Think of it as a data translator.
A translator? How so?
Well, imagine you have agent A that figures out a solution and outputs this long descriptive sentence, but agent B downstream, it only needs, say, the order number from that sentence.
The transform block sits right between them. It takes agent A's output, maybe extracts just the number, formats it cleanly, and passes only that to agent B. It ensures the data is neat and tidy for the next step, crucial for smooth multi-agent stuff.
Cleans up the data handoff. Makes sense. What about accessing external knowledge, like documents?
For that, you've got the file search block. Lets the AI search through files you upload, PDFs, text docs, whatever.
And those files live in vector stores, right? That sounds technical.
It's a special kind of database. Basically, it stores the meaning of the text, not just the words, allows for really fast, relevant searching based on concepts, not just keywords.
Interesting. Okay, what about keeping things safe? Preventing bad interactions?
Yeah, safety first. There's the guardrails block. These are like pre-built safety nets. Instant if-then rules to block harmful stuff like hate speech before it even gets to your main AI logic.
Built-in protection. Good. And sometimes you need the human back in the loop.
Definitely. The user approval block does just that. It literally pauses the workflow and asks the user, hey, do you want me to actually book this ticket? Yes or no? Needs explicit permission.
Control, like that. Then there's looping. Repeating actions.
The while block.
Yeah.
Allows repetition. Super powerful, but big warning sign here.
I know.
If you mess up the condition for when the loop should stop, you can easily create an infinite loop. Just runs and runs and runs.
Burning through credits again.
Fast. Neat. Honestly. I still wrestle with prompt drift myself sometimes, especially when setting up those loop conditions. It's just deceptively easy to get wrong.
Good to know even the experts find it tricky sometimes. And lastly, connecting to other apps. Beyond the basics.
Right, there's the MCP block, Model Context Protocol. Its purpose is connecting to external application APIs, think your calendar, email, databases.
Okay, that sounds like the holy grail.
It kind of is, but the sources are clear. Right now, it's very technical, very much developer territory for the time being. Something to watch, but maybe not jump into immediately unless you have the chalks.
Got it. So thinking about these complex multi-agent systems you mentioned, why is that seemingly simple transform block so vital again? It just formats data, right?
It ensures data output by one agent is clean and predictably usable by the next agent. Keeps the whole chain working smoothly.
Okay, let's make this concrete. Time to build our movie expert workflow. The goal seems pretty clear.
Yep. We want a bot that figures out, does this movie question need fresh, up-to-the-minute info from the web? Or can I answer it from my internal knowledge, like historical facts?
That's one. The classifier. We need an agent to make that decision.
Exactly. Drag in an agent block, let's name it web classifier. Its instructions are simple. Analyze the user's query. Does it need real-time stuff like show times or new reviews?
Right.
Or is it asking about static facts like who directed a movie years ago?
Okay, so it analyzes the question. Step 2 feels critical. Defining the output format.
Absolutely critical. We force this agent to output its decision in JSON format. JSON is just a structured way computers like to read data. Super predictable.
And within that, just JSON.
We define one specific thing. A property name called needs web search, and its type has to be bool. That means it can only output true or false. No maybe, no long explanation, just true or false.
Forcing that binary choice makes the next step simple.
Precisely. Step 3, the if-else block. We connect the output of our classifier directly to this block.
And the condition inside the if-else.
We set it to check if that needs web search value we got is exactly true. That creates our two paths instantly. True path, false path.
Okay, makes sense. So steps 4 and 5 are building the agents for those two paths. What goes on the true path?
If needs web search is true, we need an agent that can actually search the web. So another agent block, maybe call it new movie searcher. The key setting here. You must enable the web search tool for this agent, and its instructions should tell it to use that search.
Got it. And the false path. If the classifier said false, no web needed.
Then we need our movie expert agent, another agent block. Its instructions tell it, rely on your internal historical knowledge only, and you explicitly tell it not to use web search. Keep it offline.
Whoa. Okay, hang on. When you lay it out like that, imagine scaling just that core logic, that classify and route mechanism, managing like 1 billion different queries without a human touching it. That's real leverage.
That's exactly the point. Building these fundamental decision structures is the key.
So how do we test this movie expert?
Simple. You ask it, what actors are in that new movie, My? That needs current info. Classifier says true. The new movie searcher fires up, uses web search.
Okay, and the other path.
Ask, who directed the movie The Godfather? That's old, static info. Classifier says false. The movie expert agent answers instantly from its internal knowledge base. No web search needed. Works beautifully.
Right. So going back to that crucial step,
Yeah.
how does forcing the classifier agent to output only JSON with that true-false value simplify things so much for the if-else block downstream?
JSON provides a predictable structure that the if-else block can quickly and reliably evaluate. No ambiguity. Now, inevitably, when you're building and testing, things will break. Stuff won't work as expected.
Happens all the time. What's the first rule? Don't panic.
Well, yeah, don't panic, but also don't just start tearing it all down and rebuilding from scratch. Resist that urge.
Okay, so what do you do?
You lean heavily on the evaluate feature. Think of it as your debugging console, your error log, your behind-the-scenes peek.
What does it show you?
Everything, step by step. How long each block took to run, what the agent was actually thinking, its reasoning process, and the exact data output from every single block. It's the #1 time saver for figuring out what went wrong where.
Essential tool. Okay, what about making it look nicer? You mentioned widgets earlier.
Right, for polish. If you want to go beyond plain text answers, you can set an agent's output format to widget instead of text. Then you typically upload a pre-made .widget file that defines the layout.
Sounds cool. Any catches?
Yeah, a big one. Custom widget creation, building your own, still officially in beta. And the feedback is, it can be frustrating. Our sources say it works reliably maybe 90% of the time, so use with caution, expect some bumps.
Good warning. Okay, so it's built, debugged, maybe even has some nice widgets. How do you actually get it out into the world?
You hit publish. That action generates a unique workflow ID and a version number. Those are the keys.
And you take those keys.
Where?
You feed them into the chat kit configuration. Remember, the API bridge. That's how you link your published workflow ID to the front end, embedding it in your website or app.
Got it. Publish gives you the ID, chat kit uses the ID to deploy. Now, what are the big mistakes people make? The pitfalls to avoid?
#1, easily. Not testing both paths of an if-else block. People build the true path, test it, looks good. They forget to thoroughly test the false path, too. You got to test both sides.
Equally. What else?
#2, forgetting about output formats. You set an agent to output JSON or to use a widget. It's not going to give you simple text anymore. You have to make sure the next block in your workflow is expecting that specific format. Plan for it.
Data format mismatches. Classic problem. Anything else?
Yes, and this is huge. Model selection. Don't just use the cheapest, fastest model for everything. Why not?
Because for those critical logic steps, like our web classifier that has to make that crucial true-false decision, you need the smartest model available. Use GPT-4 or GPT-4o, even if it costs a bit more per query. The accuracy there is paramount.
And the faster, cheaper models.
Save those, like GPT 3.5, for the simpler tasks. Retrieving information, generating straightforward text where a small error isn't catastrophic. Use the right tool for the job.
So that leads to the question, why is using that powerful, maybe more expensive model like GPT-4 really essential for that initial web classifier step?
Because the logic is critical there. That first decision dictates everything downstream. You need the most accurate decision-making available right at the start to prevent potentially much bigger, more expensive errors later on.
Okay, so let's try and boil this down. The big idea here seems to be that Agent Builder sits in this interesting space. It's not quite no code, but it's not full-on programming either.
Exactly. It's a middle ground. And success really hinges on mastering a few core logical blocks, especially that if-else, the transform block for data, and set state for memory.
And being methodical. Using that evaluate feature constantly during testing.
Absolutely. Test, evaluate, refine. Don't try to build Rome in a day. Start simple. That movie expert example. It's a great pattern. Get comfortable with that basic classify and route flow first.
Don't get discouraged by beta features like widgets maybe being a bit flaky for now.
Right. Focus on the core logic, because the real power, the real potential gets unlocked when you move beyond just building on the canvas and start connecting your agent to the outside world using ChatKit.
Which brings us perfectly to our final thought, something for you to chew on. Once you do get comfortable, maybe even start exploring that advanced MCP block for connecting to external apps, connecting your agent to everything you use, email, calendar, internal databases. What's the single most complex, time-consuming task you could realistically automate?
Is it handling all your complex meeting scheduling? Maybe querying vast amounts of company data instantly? Or even triaging and responding to most of your incoming email? The potential is huge.
Go build something functional. See what you can automate.
We'll catch you on the next deep dive.